Welcome back, grade 9. First of all, I'm sorry for the inconvenience. As you may notice, I am quarantining in-house for rest of this week due to a little illness situation. I'm going to update you more and more in the communication app that we are using, which is either Seesaw or Google Classroom, one way or another. So today's class, actually, we're going to go into the world of powers and exponent. As you may notice, exponent is a key concept for this, and you're going to learn the whole entire rule about it. And that rule is, if you guys remember bad math, bracket exponent, and then multiplying, division, addition, subtraction, it's very similar as that, except we are going a bit more beyond because exponent has its own rule. Let's go with our first page. There's a little bit of a joke. And this actually summarizes exponents pretty well because exponents was basically invented by humanity to make our lives easier. I want you to look at the first diagram and count how many 2's you're multiplying with. There's 1, 2, 3, 4, 5. And of course, one of the easy way that you can show that 2 is multiplied by 5 times is basically 2 times 2 times 2 times 2 times 2. But instead, and what you can see in the second, we can actually shrink this expression into a simpler, and as a last, we can show 2 to the power of 5. And this 5, ladies and gentlemen, the small number on the top right side is known as exponents or power. And this basically apply for not only the number that you see like 2 to the power of 5, 3 to the power of 9, but also your unknown value, which is known as variable, x, y, z, a, b, c, those kind of guy to the power of 7 in that specific example. So have that in your mind. Today's focus will be basically the very first part, October 14, October 15 in 2020. We are going to look for repeated multiplication using power notation. Today is the first lesson, so it is quite easy lesson, I like to say. But as you may look through, you will notice that exponent rule have many different notation, and especially we call this exponent law. We're gonna follow this rule. But don't get too intimidated by the fact about a lot of letter in this case. In grade 9, we're going to learn about a bunch of natural number and integer as a basis. And I know you don't know about basis, but we're going to look at that real soon. Of course, obviously, time to time, we may do some unknown variable that go into this page. Go into each of those. We call it substitution. Let's go with our very first lesson, ladies and gents. And this is your Math Makes Sense textbook, page 52 to 57. Basically, what we're talking about is what is power. You can also write that as what is exponent. And exponents actually came from geometry situation. So little quick recall. I want you to think about this two-dimensional square situation, and I want you to write down this as an area. I want you to find the area. I know I put it 1 unit, but let's say this can be, for example, let's say 1 feet, something like that. If it's square, you know that length is also 1 feet, width is 1 feet, and then everything's shared. Now let's go with geometry situation. Area is basically your width times length. Therefore, if you actually substitute our width value and length value, then what's going to happen is area is equivalent to 1 feet multiplied by 1 feet. Instead of showing this 1 feet and 1 feet, what mathematician decided to do is basically we're gonna put exponent. If you notice from this second step, you will notice that there are twice. You multiply twice in this situation. A mathematician find and scientist too. We decided one notation and then say, you know what? If it's repeated multiplication, let's just put that how much is repeated as on top right corner. We call this 1, which is being multiplied, as a base. From now on, we're going to call it base. On the other hand, this small number on the top right corner, we're going to name it as exponent, and it tells us how many times it's multiplied. And when I say it, that's more base. How many times does the base being multiplied? And this is known as exponent, or it is also known as power. So this is one way of showing. And obviously we all know that this is equivalent to 1 feet square. And that's easy things to do in two-dimension situation. Now let's rewind the clock a little bit to grade A situation. You guys learn about volume of the cube. And it can be any cylinder too. I'm going to give you a little reminder that in three-dimensional part for a cube or cube or prism, you have width, you have length, and you also have height. And when it comes to volume of the cube or any type of three-dimensional object, you multiply all of these. So what I mean by that is length times width times height. Now let's think about some of example. Let's say in this case it's 3 inches. Let's just figure out some kind of measuring unit. 3 inches. Then here's what happened. If it's traditional way, in order to find the volume, you substitute entire value. Fortunately, we are in cube situation, so the whole numbers are basically repeated. Length is 3 inch. Width is 3 inch. Height is 3 inch. If it's traditional method, we actually list every single thing as one line. But the modern and more smarter way, I like to say, is we don't want to make a choo-choo train expression like this. What if you're dealing with 3 times and then it's repeated 50 or 60 times? That's awful to go through. Then what you can do is, first of all, identify the base. Right now, whatever that is being multiplied is 3. So my base is 3. And then you need to think about how many times. I have 1 time, 2 times, 3 times. So as total, we have 3 different multiplication sequences happening. So you can say 3 to the power of 3. And my unit is cubic inch. This is your exponent way of describing this entire situation. Instead of listing it infinitely or horizontally, mathematician and scientists decided to make it very short so that we can use the space a little better. And this, obviously, if you list everything, 3 times 3 is 9, 9 times 3 is 27, so you can conclude that this is 27 cubic inch. And obviously in this situation, my base is 3, and in this case my power or exponent is also 3. And obviously this is where tricky situation occur, where base and exponents basically share the same value. But one thing that you need to understand is still base is whatever the number that is being multiplied, and exponent is how many times it's multiplied. So have that in your mind. So let's go with our page number 4 of your booklet. When an integer other than 0, and I know this play a huge role when it comes to next lesson, but for now, let's highlight that. Other than 0, everything can be written as a product of equal factors, and we write this integer as a power. So, like I mentioned, if you look at what's being multiplied, and this what part is base, and how many part is basically your power or exponent. So in this case, my 5 is being multiplied 3 consecutive times, so we call it 5 to the power of 3. And this is the way that you speak is always you need to mention base first to the power of exponent. This is how you say. So if I look at this specific example, the way that you should read the exponent is 5 to the power of 3. That's how you read. Or sometime if it's to the power of 3, we call it 5 cube. You can also mention that. Just like if it's 5 to the power of 2, we call it 5 square. Something like that. This is a little shortcut, but the thing is, how can you say if it's 5 and 4? So as you may notice, why I'm going through this basic is because of some of the exception. 5 to the power of 4. That's what you can do. So in this case, ladies and gentlemen, base is 5, exponent is 3. So like I mentioned, in situation, we can refer it 2 different ways. 5, 3 can be written as 5 cube. Or another way, 5 to the power of 3. Or 5 to the third is another way that you can use. And again, it's your choice. So let's deal with some of the example. Identify base of each power and then evaluate the power. Before we getting into, evaluate is a fancy way of saying calculate. If you're dealing with any type of calculating situation, here's a little step that I suggest. Number 1, I want you to think about sign first. And when I say sign, is it positive answer or negative answer? And number 2, your product. That is basically a fancy way of saying your quantity. So how much total? So let's tackle this problem, each of the situation. The first thing first, 3 to the power of 5 or 3 to the 5th. Now, when you look at this situation, let's think about it. I have nothing in front. That means I should have positive answer. So first step, check. We know it ends with positive. Then after that, what we generally do at the beginning is we list. Like traditional way. Instead of the shortened word to the power of 5, we're listing 3 times 3 times 3 times 3 times 3. I know it looked like a sucker, but bear with me. And then, and as you may know, I'm limiting the calculator use for a certain amount of classes at the beginning. I pick and choose. What I mean by that is pair up. 3 times 3 is 9. 3 times 3 is 9. Then 3. Pair up. You guys learned about bad mess before, right? 9 times 9, that's 81 times 3. And lastly, we know that this entire answer is positive 243 or just 243. I will accept both. in high school. This is more correct answer, however. So it's a good idea to adjust. Now let's look at the other situation. Where does the B go? Seems like A, C, D, E. So the messed up situation happened. But in any case, I want you to think about the sign first. Let's not think about our quantity yet. So very first situation, I have -3, that's my base. But it's multiplying 3 different times. So it's like negative multiplied by negative. Can you see that in this situation, if you just purely think about the sign, negative and negative will make positive if it's multiplication. But positive and negative will eventually give you negative answer. Some people memorize in terms of, oh, okay, if there's an odd number set of negative that is multiplying, that it will end up as negative. Even number set will give you positive, then you can put positive. Feel free. In this case, you know that from the process of bad math left to right situation, you know that it will end up getting negative. After that, what you can do is list the quantity. Now this time I'm gonna include the sign just in order to prove the point. The next example I won't. Can you see it? It's bracket and then have an exponents. So that's a fancy way of saying -3, -3, -3. You know that negative and negative and negative, that will give you negative at the answer. So in the end, you can kind of consider like this and pair them up. 3 and 3, that's 9. Like that. And 9 times 3, that's 27 with the negative sign. That's how you do. Next one. This time it's quite tricky. Know the fact that when it comes to the previous example, sign was included, ladies and gentlemen. But the next example, you will notice sign is not included. So that is a fancy way of saying this negative and 3, it's independent. So negative is just by itself, which eventually give you the idea the answer will be negative. Now what I need to do now is basically, we know the sign, and you just multiplying 3 times 3 times 3. Again, the difference between the left example and right example is the left example sign is included, so we went through the process of multiplication of different sign to get my final conclusion of the sign. On this case, it will be always negative. So what I mean by that is even if -3 to the power of 4, only the quantity 3 is being affected by the exponent, not the sign. These two are separated. Have that in your mind. But after that, 3 times 3, that's 9. 9 times 3 is 27, so you will get the same answer. This is a tricky situation just because when it comes to that example D, you know that sign is not included. That's why. Next one. Some people freak out because of this situation. Now, first thing first, you need to identify is my sign is included. No. If you look at exponent, only 3 has a sign. And now, we need to think. You have negative inside of the bracket and negative outside. So, if you have negative outside and negative inside, that's a double negative. That means everything will turn into positive. And this is my first step, identifying the sign. But once that is done, here's what you need to do. 3 times 3 times 3 times 3, negative, negative. That's basically what this situation is look like. Again, negative doesn't include it by this to the power of 4. If this is included, then it should be look like this, where exponents is outside of the bracket. But in any case, 3 and 3, that's 9 and 9. And as I mentioned, negative and negative turning into positive. So in the end, 9 times 9 is what you need to do, which is equal to 81. That is today's lesson.